If humans want to go where no one has gone before, and yes, that's a Star Trek reference, they'll need to solve the problem of food. They won't be able to bring everything they need from here, and they'll have to find a way to source it out there. However, that ingenuity could end up also helping us back here. A new book examines all that. It's called Dinner on Mars: The Technologies That Will Feed the Red Planet and Transform Agriculture on Earth. And with us now for more, the co-authors of said book in Rome, Italy, Lenore Newman, Director of the Food and Agriculture Institute at the University of the Fraser Valley, where she's a Canada Research Chair in Food Security and Environment. And in Guelph, Ontario, Evan Fraser, Director of the Aral Food Institute and a Professor of Geography at the University of Guelph. And we are delighted to welcome you two back to our airwaves tonight here on TVO. Lenore, get us started. How did the pandemic help create this book in the first place?
Yes, it is kind of strange that this book came out of being trapped in a very small enclosed space, much as if one was on a trip to Mars. Although I didn't expect the pandemic to actually last as long as a trip to Mars. But when Evan and I were stuck when the pandemic unfolded, as most of us were, we started chatting about, well, I guess we can't go to this research site or this research site. We might as well be on Mars. And the idea came up then, well, what would we eat if we were there?
And Evan, your response to her asking that question was what?
Well, it was such a silly conversation at first, right? But I mean, everyone was bored and didn't have any toilet paper, or we all had our toilet paper in our basement. There was none in the stores. And it was that, it was a very fraught moment in the spring of 2020. And my response was, well, let's take it to the back to the basic building blocks. Like, could we imagine building a food system on another planet where solar radiation is scarce, where there's hardly any water, where every organic molecule you're going to use needs to be created somehow. And it was it was started as a silly thought experiment, and it morphed into a serious thought experiment that then took form in a book. Yeah, so taking it back to the beginning.
And here we are. Well, let's do a little quote from this originally silly and now serious thought experiment. And here's a quote from your book, Dinner on Mars. As the two of us have gone on this imaginary mission, we have come to believe a Martian community can and will feed itself successfully, and that in doing so, develop technologies that will revolutionize agriculture on Earth. Seem preposterous? We don't think so. In our opinion, figuring out what the first Mars dwellers will eat is a topic that may define the future of how we feed ourselves. This is fascinating because obviously all sorts of people have thought about what colonizing Mars would be about, might look like, but I'm not sure anybody's ever taken the next step to think about how people on Mars would actually feed themselves. So you've done us a service by getting there. Lenore, how did this get on your radar screen in the first place? The notion of that next step, how people are going to feed themselves on the red planet.
Well, I think Evan and I are both kind of odd people in that our actual day job is looking at the terrestrial food system, and also we're both science fiction buffs. And I think we've watched the question of food be kind of waved away a lot in the popular press in space. And of course, existing space missions have always taken takeout with them. Very, very expensive takeout. And when you make that next step to Mars, we realized that is a critical element because it is too far to bring food with you. So you have to build it from scratch there, taking as little as possible along for the trip. And when we started, to be honest, we were not sure we had the technology yet to solve this problem. And I mean, the kind of spoiler alert is we really do think we could do it now, but it took a little bit of intense thought experiment to get there.
Well, let's see how that works, because presumably, I mean, it's not going to happen today, but Evan, take us 50, 60 years down the road. What's the foundation of a Martian-based food system then?
Yeah, so the punchline is the technologies are almost ready, but not quite ready. So this is near future technologies. This isn't Star Trek replicators. And for me, it all starts with the humble cyanobacteria, which is sometimes called blue-green algae. It's the stuff that often grows on a summer's afternoon in Lake Erie and creates these huge algae blooms. And on Earth, it's a response. Plants or lakes get filled with often agricultural runoff, fertilizer off the fields, and the lake's ecosystems go crazy producing cyanobacteria. What I learned in going down one of the many rabbit holes that this book took me down, what I learned is that there's a group of scientists in Germany who have reconstructed what's called Martian regolith, basically the sand of Mars. And they've reconstructed the chemical components of it. We know what it looks like from Martian rovers' works in the past. And they've shown that actually using ingredients only found on Mars, you can grow cyanobacteria. And in doing so, the cyanobacteria helps neutralize a very toxic substance. And I've only ever read it, so apologies if I'm mispronouncing it. It's either percolate or perchlorate. It's a chemical compound that in very small quantities will give lung cancer to humans, and it's all over the Martian sand. So you need the cyanobacteria to do two things. First of all, to turn the basic ingredients that you find on Mars into organic matter, and second, to get rid of or neutralize these percolates or perchlorates. And so I think the basic foundation of a Martian community would be a large stainless steel vat kept warm by solar radiation, probably using some concentrators or some mirrors or some fiber optics to concentrate the sun's energy. Because remember, Mars is quite a bit farther from Earth, so there's less sun's energy out there. Mm-hmm. Have to shield out the harmful radiation, so you'd probably bury the thing. And you would produce cyanobacteria. And with the organic matter produced by the cyanobacteria, you would then build vertical farms and other sorts of bioreactors to produce proteins. But I think the basic workhorse of a Martian food system would actually be blue-green algae, more properly known as cyanobacteria.
Okay, in which case, Lenore, how complicated would it be to create? I mean, Mars is a pretty inhospitable planet by Earth standards. How hard would it be to create soil where you can grow something?
Well, I think the first thing is I'd probably skip the soil, which is part of my day job as well. And I really think the backbone, the workhorse, once we move up from cyanobacteria, is going to be hydroponic plant systems, to the point that living on Mars will feel very much like being in a garden, in that there'll just be plants everywhere. And that's partly for food, but they'll also play a really critical role in providing base organic material and also recycling oxygen and recycling the water. So anywhere you look, there's going to be a plant, and most of them will probably be useful. And that was one of the big things we came to realize. On Mars, the plant is going to be king, and it's much harder to keep anything else alive. And the plants will probably do pretty well. And in fact, it would be much easier to populate Mars if we didn't have people. They're kind of the weak point in the whole system, is having to keep these really annoying movable organisms alive. But, I do really like plants. So think of it as building a garden based on algae.
Sounds like you like plants more than people. Is that right?
Some days, definitely.
Some days.
Yes.
Okay,
they're quite a bit more complicated than us. It's one of the weird quirks I love telling my students is corn has a much more complicated genome than people do. And so it might be why the corn is kind of taking over and maybe actually in control.
Gotcha. Okay. Evan, talk to us about nanotechnology and the contribution it can make to creating a functional food system.
Well, I mean, there's a tremendous amount of really interesting things happening at what's called the nanoscale. So that's bigger than molecules, but smaller than anything that humans can sort of interact with. So this would be like the, 1,000th of a hair follicle in sort of size. And a lot of neat stuff happens at the nanoscale. And another of the rabbit holes that this book took me down was conversations with really serious nanotechnologist scientists. And there's really sort of two things, or a number of areas in which nanotechnology can help. First of all, if you create these really, really tiny balls of starch, which actually are naturally occurring in sweet corn, you can put little tiny bits of fertilizer or medicine, and on Earth, actually, the gold standard or the holy grail of this is to put tumor-fighting cancer drugs into these little tiny balls of starch and then key them so they actually get into a tumor or get into a cell of an organism and release either the nutrient or the toxin or whatever you're trying to do. So nanotechnology essentially offers us a way of being orders of magnitude more precise with, say, inputs. If you could use nanotechnology to sort of deposit that molecule of nitrogen into the plant right where it needs it, you'd have virtually no waste. So that's sort of what the nanotechnologists are working on. The other thing is what's called carbon nanotubes, which would be these 1 atom thick tubes of carbon where the sides of the tube are 1 atom thick. And these are incredibly strong, incredibly flexible, and are increasingly being used on Earth for all sorts of crazy applications. Apparently they were even, you can find carbon nanotubes in Damascus steel swords from the Middle Ages. So there was some very, very sophisticated smithing going on 1,000 years ago in Saudi Arabia and whatnot. But at any rate, these nanotubes can be used for all sorts of materials. And so between a delivery mechanism and really, really strong flexible materials, the whole wild world of nanotechnology offers us tremendous opportunities, I think, if we're trying to do something in as inhospitable an environment as build a community on another planet.
And Lenore, do I infer correctly that this hydroponic plant system, which is going to be the basis of the food system on Mars, that system will produce the majority of the food that people on Mars will eat, however many years down the road?
Basically, in a nutshell, yes. There'll be kind of 2 main tracks where we get the cyanobacteria. We'll do 2 main things with it. One is produce plants. And of course, we like those. So fruits and vegetables, that'll be quite easy to take care of. Protein, though, is going to be a bit of a trick in that here on Earth, of course, the majority of protein is still animal-based, and we know it's really inefficient. And even on a planet as lush as ours, we are having trouble producing animal protein for everyone without causing serious environmental damage. On Mars, it's just impossible. Animals are too inefficient to take part in that. It would you wouldn't be able to create enough protein. So protein on Mars might be plant-based, but it will also more likely be fermentation-based or grown in the lab. And a lot of people have probably heard about breakthroughs on lab-grown meat and sort of wonder, well, that sounds pretty Star Trek. It can't be that close to development. But the reality is it is pretty close to development. And Evan and I actually got to go down to San Francisco and try some salmon that have been grown in the lab. And it's almost Mars ready. So I think that'll be one of the sort of surprises to us is it will be a system where everyone's eating a plant-based diet, but they won't really entirely notice because the meat will be there. It'll just come from the lab or through fermentation. The one trick and the thing that I think we are still thinking will be a real struggle is here on Earth, we really do rely heavily on carbs, almost to excess, because they're really easy to grow. On Mars, carbs are going to be kind of expensive. So spaghetti might actually be a bit of a treat meal in a Martian community because we just won't be able to grow carbs the way we do here. They take too much space.
So, well, you're in Rome right now, so I got to ask this question. No pasta? No pasta in Mars?
Well, there's going to have to be some, or the Italian astronauts will not cope without their pasta. It's a very carb-heavy diet here, so definitely there will have to be some carbs, but they'll actually be somewhat more expensive in terms of energy to create than some of the other foods, and that's kind of backwards to the way it works on Earth.
Mm-hmm. Okay, Evan, cheese. Will there be cheese on Mars?
Yeah, well, I mean, we're going to go back to that conversation or that comment Lenore just made about fermentation. And, humans have been fermenters for almost all of our history. Some would argue all of our civilized history, and maybe civilized history starts with fermentation. But in all seriousness, we have utilized microorganisms, often yeasts, but not always yeast. Sometimes it's a fungi, sometimes it's a bacteria, to turn some sort of starch into something that we care about, like alcohol. We do this on all sorts of things. Kimchi would be a great example of a vegetable ferment. And now we've been using what's called precision fermentation in labs and in our food system for about 30 years here on Earth. So the first big breakthrough was in the 1990s when the world's insulin supply for diabetics shifted from animal-based insulin to insulin. And basically what happened there is that scientists bioengineered a microorganism to produce insulin instead of producing, alcohol or carbon dioxide or other normal things that fermentation does. Another big breakthrough was in the early 2000s when scientists engineered a microorganism to produce rennet, which is the enzyme that produces cheese or used to curdle cheese. So at that point, about 20 years ago, most of the world's rennet shifted from animal-based rennet to fermentation-based rennet. Well, there's companies springing up all over the world right now who are using microorganisms to ferment all sorts of proteins. And another of the products that Lenore and I sampled for this book was what came out from a company in San Francisco called Perfect Day that has a microorganism that produces whey protein. So this is exactly the same protein as cows produce, except it comes out of a microorganism. It doesn't come out of a cow. And they're producing ice cream and cream cheese, a couple other products. And they're great. They are fabulously good quality products. So our hypothesis is on Mars is that, yes, there will be cheese, but it will come from a fermentation-based protein as opposed to an animal-based protein.
But it sounds like, Lenore, you're both saying it will be a lot easier if the Martians of the future are vegans. Fair to say?
I think they will be simply for energetics reasons. And I actually feel that will trickle back to Earth in a lot of ways. And we're already seeing that. We're seeing a rise in plant-based diets globally now. I mean, there's some ups and downs in local markets, especially in North America. But we are seeing more substitute protein products here on Earth. I think on Mars it's a given. And because these products will be identical, no one's really going to miss the bad environmental outcomes of animal agriculture or the animal cruelty element. And I think philosophically it'll be very interesting to see how that develops on a different planet. But I do agree with Evan. These are not going. This isn't going to be a civilization of people with no bad habits. They will definitely have alcohol.
Yeah. Okay. Huh. How are they going to are they going to be able to create it on Mars, alcohol?
So if you can produce starches quite easily, potato, for instance, you could grow potatoes, you could synthesize sugars in a number of different ways, and then ferment it. So I think vodka-like drinks will be quite common. There might be a little bit of barley grown around a Martian, a domed Martian crater with a bit of a lake in it. One can imagine, a little fanciful, but what the hell? Maybe there's a Martian bourbon in the future or something like that. But certainly a potato-based ferment would doesn't stretch the imagination, and that's practically what Matt Damon did in the movie The Martian. I mean, he didn't make the booze, but he was growing the potatoes.
So you're not going to be able to call it gray goose. You're going to have to call it red goose or something like that, given it's the red planet.
Red goose, yes, for sure.
Yeah. Someone was laughing about space side instead of space side whiskeys. Anyhow.
Lots you can play with there.
Lots of fodder for puns.
Well, tell me this: if the food system is going to be completely different, will there be garbage on Mars in the future? Lenore.
I think we'll see very little waste on Mars. Anything that can be recycled will be recycled, and we'll really see tight closed loops because we're putting so much energy in at the front end to create that cyanobacteria and then build it up into a system. And those technologies will be exported right back to Earth because we need those today.
Well, that gets to my next point, Evan, which is this started as a fun thought exercise, but presumably some of the things you learned in the course of writing this book could be very helpful to averting food crises here on Earth today, such as, for example.
Yeah, so this is where it gets deadly serious, and the joking drops away, and the goofiness of this thought experiment vanishes. And I think there's two things that I'm going to take away from writing this book with Lenore that are directly applicable to Earth. And the first is not the technologies, but the mindset of incredible efficiency, the mindset of figuring out how to use the waste products of one part of the system as inputs into the other. So the waste product of the cyanobacteria tank becomes the inputs for the vertical farm to produce the vegetables. And it's that mindset of incredible efficiency and closed loops that we desperately need here on Earth. And if I have one hope for this book, at all. It's that it communicates that sense, not of the wonder of the technology, but that sense of needing to be more efficient and develop closed loop systems here on Earth. So that's the first thing that I really think that this becomes deadly serious. The second thing that becomes really serious is that while Lenore and I got excited about the technology, this is not a technotopian technology will save us. The technologies we're describing are amazing, but they're not panaceas, and they need to be backed up with really smart, good policy and economic incentives to use the technologies right. So, for example, if one of the benefits of producing all this food on essentially no land on Earth is that we could maybe imagine freeing land up for nature if we don't need as much farmland, that extra farmland that isn't needed anymore. Well, that has to be protected. You can't just turn that into an Amazon fulfillment center or a subdivision. You actually have to protect it. And people that are currently own that land need to be compensated for what's happening. And so there's a whole lot of policy implications and societal questions that come out that are really, really serious. And I think doing the thought experiment of Mars helps point us in the way of thinking of some of those solutions.
We are happy to remind people that for more, both serious and silly ideas, these two have collaborated on Dinner on Mars, the technologies that will feed the red planet and transform agriculture on Earth. Lenore Newman, Evan Fraser, thank you so much, as always, for joining us on TVO.
Thank you.
The Agenda with Steve Paikin is made possible through generous philanthropic contributions from viewers like you. Thank you for supporting TVO's journalism.